All right, well, the camera died again. Every time I go to move it, it doesn't like it. But where we were was just leaving the month of September for our journey around the sun. We're going to go through the autumn, and we will end up again over here, which hopefully you remember from a few previous videos, that this right here then represents where the Earth would be during the month of December. Okay, and what you can see is the north pole of the Earth is pointing away from the sun, which for you guys, the sun is right behind the camera here. So you're looking at the sun. You can tell, or at the Earth, you can tell the sun is shining more directly on Australia than it is on, say, the northern hemisphere in Asia. So this is summertime in the southern hemisphere, the beginning of winter in the northern hemisphere. We're in December. Okay, the solstice is what we're referencing in this particular orientation around the orbit. So this is going to be in the northern hemisphere when you have the fewest hours of sunshine. In the southern hemisphere when you have the most hours of sunshine. All right, and when the Earth is moving along this particular axis in this particular location, the constellation that it lines up with when we talk about an orientation from the sun, which is from your perspective out to the Earth, where we end up at, where the Earth happens to be, is in a constellation called Cancer, which I'm sure you've all heard of in terms of that constellation. I don't know if you can read that, what I just wrote. Yeah, you can kind of read it a little bit. The Earth is in the constellation Cancer. Okay? But what I want you to realize, though, is what we said last video. Doesn't really matter where the Earth is, because when folks were coming up with these explanations or with these astronomical observations, they thought the Earth didn't move, it was the sun moving around it. So what I'm going to do again is represent somebody on planet Earth as the Earth is rotating. Right now, this is high noon for this particular meridian. As that meridian orbits, we're getting closer to sunset. And right here is when this person sees the sun set. All right. And now this person is in darkness, and it's midnight where this person is, and I'm going to keep coming around. And when you can see that pen cap, can you see the pen cap? Whatever instant you can see that pen cap, the person has to look towards the sun to see the sunrise. Okay? When that person looks towards the sun to see the sunrise, that sun will be in a particular constellation. And as the sun rises, it will drown out those background stars in that particular constellation, or all of them really. But when the sun rises, it will it will stay in that constellation. Okay? The constellation that the sun appears in when it rises during the shortest day of the year in the northern hemisphere, fewest daylight hours, longest day of the year in the southern hemisphere, greatest number of daylight hours. That constellation along the ecliptic happens to be Capricorn. All right, so what I'm going to do is I'm going to rotate this camera again, and hopefully the camera stays happy. Don't die on me. Come on. Boom. And again, what are we eyeballing here? You see, let me go this way a little. And you can tell where I still have the month of June written here. So the Earth would be in this location it's going around, but we're not. We're looking at where the sun is located along this pathway. Just look towards the sun as the sun is rising. And you will see it be in the constellation, oops, that's a P-R, is Capricorn, okay? So in that constellation Capricorn is where the sun will rise on that day, December 21st, okay? Now, here's another interesting thing about it in terms of Capricorn. I'm sure you've all heard of Tropics of Cancer, Tropics of Capricorn. And the boundary line that marks the southernmost tropic here on planet Earth is in fact the Tropic of Capricorn, which is labeled for you right there. But anyway, Tropic of Capricorn, you already know that latitude. It's negative 22 and a half. It's 22 and a half degrees south of the equator. Now, the reason that's called Capricorn is what I just explained to you. That's the day that the sun goes highest in the sky in the southern hemisphere, which means the lowest negative number it gets. That's negative 22 and a half. So that particular location on planet Earth is when the sun gets as high in the sky it could possibly go towards the south. So that latitude became significant. They called it the Tropic of Capricorn. This then is the first day of winter for the northern hemisphere, first day of summer for the southern hemisphere. So sometimes, again, they get away from calling it the winter solstice. It's kind of what we've grown up calling it, but they're just going to call it the December solstice. Okay, that's when we have the shortest number of daylight hours up here in the northern hemisphere, longest number of daylight hours in the southern one. Okay, but anyway, that's just kind of neat and interesting, the reason why it's called Tropic of Capricorn. What I'm going to do is keep going around in our journey, and I'm going to go back to where we were as I'm pointing back towards what again we saw is March. Okay, so remember, as I'm going, we're into the winter months through here, and we're orbiting and we're going towards spring, and this then is where the sun, or I'm sorry, where the Earth is located during what we call, obviously, the month of March. All right. Now, what you can tell is this is now when the Earth is located where we said the sun was located in September in the constellation Libra. The Earth now is at that same location. All right. 6 months ago in September, the sun, when you looked from the Earth, you looked towards the sun and it appeared in that region of the sky. Well, now, in the month of March, the Earth is in that region of the sky as it's orbiting. So we're going one of these here. And remember, we're moving from the doorway this way through our orbit. So now, when the Earth approaches from this direction, boom, hits that same spot. The Earth now is in that constellation Libra, but it doesn't matter where the Earth is. Okay, remember that. It doesn't matter where the Earth is. What matters is where does the sun appear when the sun rises. Okay, so let's do that simulation again. This person on planet Earth is at noon, and then they're experiencing evening, and when they get to this location, they're entering a shadow, and so this is sunset, and I'm going to keep moving, and this person is at nighttime. Right here, we're at midnight, and right here, when you can start to see that pen cap, which is in right there-ish, okay? That person looks towards the sun to see the sun rise, all right? When that person looks towards the sun to see the sun rise, what that person is looking towards is the location where the sun hits the intersection of the ecliptic and celestial equator, which I will rotate again to get you back to that perspective. So again, now, what the person on Earth is seeing as it looks towards the sun, right, which is right here, and then continues to look towards the background stars. So the constellation that the sun is rising in, These are the background stars, and as the sun comes over the horizon, it will fade out all of those background stars because the sun's awfully bright. But the constellation that the sun initially rises in this location, I'll try to write it as big as I can here, but I don't know if you'll be able to see it. But it's A-R-I-E-S. Okay, hopefully you can read that. That's Aries. That is when, or that is where the sun rises, or the constellation that the sun is rising in, the background stars, when it crosses the celestial equator. And that happens in the month of March, usually around the 21st-ish, which we call the vernal equinox. But again, we're getting away from calling it vernal or autumnal because it's only vernal in the northern hemisphere. It's the March equinox, okay? That is what we define as the beginning of the celestial new year, if you will, when the sun rises first in Aries, okay? When the sun first appears in Aries, that's how they define, say, a zodiac calendar or whatever. Now, again, I'll go over it a little more in a bit when I get through all of these. But so remember, that corresponds to a certain right ascension, if you can still see the RA above it, because this is the prime meridian, if you will, of the sky. This is the first where we're going to say, all right, we're going to start counting here, and we're going to go up to 24 as we go around that circle. So what you could very easily do is just Google what is the right ascension of Aries, and you would expect it to be 0. But guess what it isn't? It isn't 0, and I will explain to you why it's not 0 here in a bit when I get through going all the way around the year, when I get back to it. But when this was initially being published and studied and observed, the constellation that happened to coincide with the location where the ecliptic and celestial equator intersect was Aries. Remember what I said before, ain't nothing lasts forever, kids. So anywho, March 21st-ish, first day of spring, 12 hours of daylight, 12 hours of darkness. It's an equinox. The March equinox is when the sun is appearing in Aries. Now, again, what you can see here is this is what I had written as the month of September, but that's where the Earth would physically be. But again, it doesn't matter what the Earth is doing, because at that point in time, they didn't even know the Earth moved. So it's all about where the sun is on those particular days, okay? So as the sun moves along the ecliptic, when it hits that section, that location where the celestial equator intersects it, we call that the vernal equinox. That's going to be the first day of spring in the northern hemisphere. Sometimes we just call it the March equinox, okay? Now I'm going to go back to where we're at again in March, and the Earth is still rotating this way while it's still going to revolve around the sun. All right, so we're still going to do this, and I'm going to put the sun or the Earth where it belongs relative to the sun, and hopefully it ends up being nice. Be nice. Okay, now you can tell your perspective relative to the sun, can't you? I'm going to move it so it'll be a little easier for you to see on the video here. But boom, all right, June. All right, now you can see this. You can tell the northern hemisphere is pointed more directly towards the sun, can't you? And we're getting very direct sunshine in the northern hemisphere. We're getting very indirect sunshine in the southern hemisphere. So this is June now. June 21st is the date I want you to associate with it. This is when the sun will rise the highest it will go in the northern hemisphere. And as it rises, it will be the lowest it goes in the southern hemisphere in terms of closest to the equator. farthest from the equator in the northern hemisphere. Okay, and this then June 21st, we call it the summer solstice. Again, we may just call it the June solstice. Okay. Now, what I want you to then think about, though, is remember the planet Earth is in the constellation Capricorn at this location. It's in the constellation Capricorn. But remember, it doesn't really matter where the Earth is, okay? What we're going to focus on is the sun relative to the Earth. So if I am experiencing sunrise on the planet Earth, okay? So coming, this is sunset, and this person is in darkness, and we're at midnight here. And as this person now sees the sun rise and looks towards the sun, as the sun is rising, there are background constellations. The sun, as it rises, will make those background constellations fade out. But when it is rising, the constellation that the sun happens to rise in is, if you remember, I still have it written on the board over there. If you don't remember, then I will show you if you can still read it. It's in Cancer, the constellation Cancer. So the highest latitude on planet Earth in the northern hemisphere that the sun will rise on that particular, or that the sun ends up climbing to on that particular day, is 22.5 degrees north. That particular latitude became called the Tropic of Cancer for that reason, because that's the constellation the sun rises in on the day it happens to climb that high in the sky. All right, so I have 4 constellations written across the whiteboards here that show you significant locations of the planet Earth and its orbit, but really the sun where it is along the ecliptic during those months. Okay, and I want you to remember those in terms of where the sun appears. All right. Towards that direction is Libra. The sun appears in Libra, not in March, but in September, okay? And where I have written here, it stayed nice, it didn't die. Thank you for not dying. Not in December. When the Earth is there in December, the Earth is in Cancer. But when the sun is there is 6 months later, that is in June. Okay. So what is written on those pieces of paper is where the Earth is at that time. So the Earth is there in March. It is in Libra. But you see, I have it written as September Libra on the whiteboard. So that's where the sun is. That's where the Earth is, or the time. Okay. This one over here in June, the Earth is in Capricorn. Okay, in June, the Earth is in Capricorn, but the sun is in Cancer. Okay, so then Cancer, that is what I will write over here as June. All right, so you see how I have June written here. That's where the Earth is, or the time of year on Earth, and it's Capricorn. Okay. On the other side of the orbit here, I'm going to go over there. In June, the sun appears in Cancer. Okay, in June. Let me get back to that. Okay, June, Cancer, Capricorn. Okay, and let me go back to this here. And boy, that is awful bright, ain't it? Yep. But now he's okay. Capricorn. So in December is when the sun appears in Capricorn, which is again why we have the southern hemisphere labeled Tropic of Capricorn. And then I'll go back to here where I started our journey across the sun. And the only reason, again, I started there is because that's where you could see the whiteboard most easily, is when it's the month of September on planet Earth. That's where we're at. Then in September is when the Earth is in the constellation Aries. Okay? But as the sun rises, and you look to see where the sun rises in, is why I wrote September, the sun rises in Libra on the far side. Okay? So September. So then the sun rises in Aries in March. So this is, again, March. For the sun, it's March. For the Earth, it's September in terms of what time of year is the object at that location along the orbit. All right, we always remember, just focus on the sun, because folks didn't even know the Earth was moving. Okay, so as we go around the journey that is 1 year in the month of September, the planet Earth is in the constellation Aries. Okay, the sun is on the opposite side of the room. What I wrote on that side is Libra. The sun is in Libra. Okay, in December, as I go over here, in the month of December, the Earth, in the month of December, the Earth is physically in the constellation Cancer. Okay, but to look towards the sun and see the constellation that the sun is in, I would have to look on the opposite side of the room, and that is in Capricorn. All right, in December, the sun will rise in Capricorn. Coming back this way, when we're back to March now, and let me go this way because I want to disturb it as little as possible. Boom. In the month of March, the planet Earth is in the constellation Libra. The planet Earth is in March. Okay? But as I look towards the sun, where the sun is located as the sun rises is what I had written over here during the month of March. The sun rises in Aries. Okay, the sun rises in Aries over there. All right, now, what I said before, now that I've explained all of that to you, guess what is no longer true? And what is no longer true is in the month of March, the sun rises in Aries. Okay, what I'll draw for you in a little bit are the various seasonal constellations, where what constellations you associate with certain seasons, and you'll see this location stays fixed, but the constellations in the background tend to shift. Okay, if you're to look up what I said, the right ascension of Aries right now, in the year 2020. Let's see if this works here. Yeah, it works. Aries would have a right ascension of dancing around 3-ish, which you may or may not be able to see that, but Aries would have a right ascension of dancing around 3-ish. That, again, is due to something called precession. And again, the only reason of bringing that up is because there will be some YouTube haters saying, V, you're wrong. It doesn't do that anymore. Remember, nothing lasts forever. That's the phrase I use about precession. Nothing lasts forever. So what I have listed in this whiteboard, or in the classroom there, is the North Star. You see, I just put a piece of paper up here to represent a fixed location, to represent the North Star, just so we always had a reference point for the North Pole of the Earth to always point towards, right? Well, wasn't always the North Star, and it won't always be the North Star, because the axis of the Earth does in fact tilt a little, very, very, very slowly. We're talking tens of thousands of years, okay? But many thousands of years ago, when this sort of information was being studied and recognized and recorded, the sun did rise in Aries on March 21st. And in fact, it used to even be prior to that. I think it was Taurus prior to that, and then it was in Aries. Now, the constellation that the sun rises in March 21st is Pisces. And that'll be true for, I don't remember how many, couple hundred some odd more years. And eventually, the location of the ecliptic in celestial equator won't change. Remember, the background constellations will. Eventually, it will leave Pisces and it will enter Aquarius. And that's when we'll enter the age of Aquarius. But again, it just means nothing lasts forever, folks. All right. What I just described to you about Capricorns and Cancers and Libras and Aries that was true when all of this science was first being published and studied and observed and recorded. But as time goes on, Mother Nature, she's very slow when it comes to this sort of thing. But the North Star, ain't always going to be the North Star. All right. It used to be many thousands of years ago, a star in the Big Dipper was the North Star. Many years from now, it will be Vega as the North Star, and then it will come back around. And so everything is just cycles. Okay. But if you look up right ascension of Aries, you'll have to, when you look up right ascensions of various objects, won't have to, but it will tell you what it is right now. It may say, well, you got to give me a century here. What's the right ascension of Aries in the 1700s? It would be different than the right ascension of Aries now. Not a lot, but a little. You could look up the right ascension of Aries 2,000 years ago, and it will be different from what it is now. So right ascensions change. Declinations, not so much, but right ascensions do. Again, but what I described to you is the basis of the seasons and the start of the celestial new years and what have you. But please don't think I was lying to you because I gave you that information. It just is what it is. Mother Nature is a very slow to change her mind type of person. And through thousands of years, those things can change. All right. But anywho, with that, I'm done explaining the equinoxes, solstices, and the constellations that the Earth and the Sun are in. The next thing I'm going to do is just tell you a little bit about what constellations you can expect to see during any given season and the ones that you can see year round. All right. Yay, physics.